Welcome everyone. Friendship is a mutual relation, and today we are going to solve a problem related to friendship. Consider a set S, and this is the question that describes a set S. Set S consists of people, some of them are friends and some of them are not friends, and it's a mutual relationship. Suppose if A is a friend of B, then B is also a friend of A, like that. Under this scene, there are certain conditions given. Any two with the same number of friends inside the set S will have no common friend. Like if suppose the person A has 5 friends and person B has also 5 friends, then it will turn out that the friend set of A and the friend set of B will not have any intersection. There is no one person common in their friend list. If that is the case, then can you prove that there is a person inside the set S with exactly one friend? Let's get started. So here is the question. I insist you to try this problem on your own and then look at our solution. We are just going to use some simple logic, no formulas, no theorems, nothing. Consider the set S. This trick is sometimes called as extremal principle. You are going to focus on the person with maximum number of friends inside the set S. There could be multiple of them. If there are multiple of them, just consider one of them. Since it is a finite set, there must be one with maximum number of friends. Let's call that person to be X. Now we have the friend list of X. So these are the friends of X. Maybe it is just one person, in which case we are already done. That's what is supposed to be proved. Let's call this friend list of X as P. Let's analyze the people or person in P. Assume that the people inside P are like F1, F2 till Fk, where K is the cardinality of P, the number of people in the set P. It is easy to note that no two of these Fi's can have same number of friends. The reason being that if suppose F2 and F4 have same number of friends, they must not possess a common friend, but in fact the person X who has the maximum number of friends in the set S is a common friend, which contradicts our condition. So we do not have two people with same number of friends inside the set P. Therefore, I can assume that these people will have different number of friends. Now if suppose one of them have exactly one friend, we are already done proving the question. So we will assume the least number of friends with any of them is 2. Then if you assume that as 2 for F1 and we assume that the number of friends of F1 is strictly less than F2, strictly less than F3. So we are naming the friends as F1, F2, F3 based on the ascending order of arrangements relating to the number of friends of them. So F1 is assumed to have the least number of friends. Therefore, if F1 is 2 or greater than or equal to 2, F2 will be greater than or equal to 3. Because F1 and F2 can't be the same. F3 must be greater than or equal to 4. So on up to Fk must be greater than or equal to k plus 1. Now, come back to our assumption. We assumed that X has the maximum number of friends. Maybe there are multiple of them with maximum number of friends, but no one in the set S has more number of friends than that of X. But you could see that the person Fk has k plus 1 friends, which is greater than the number of friends of X, which is k. Because we assume that k is the number of people in the set P, which is the friend list of X. So k is the number of friends of X, but Fk having at least k plus 1 friends is a contradictory condition, or it's a contradictory circumstance. Therefore, the assumption that F1 is greater than or equal to 2 is not possible at all. And clearly, none of them F1, F2 till Fk have 0 friends because they already share a friend with X. Therefore, we prove that the number of friends of F1, that is the least number of friends in the set P, will be 1. So by this way, you end up proving that there exists a person inside S with exactly one friend. This is actually a problem in one of our fortnight worksheet of level 3. We discuss such interesting logical thinking type questions. We model and inspire questions based on Russian math Olympiads and mathematical games, which are not conventional problems in the realm of our students. So we are now catering students in India as well as some of the students from abroad, and we hope that these kind of problems inspire and excite you. If you are interested, you may also subscribe for a free trial worksheet by applying through www.sumonmath.com. See you soon everyone. Bye.